So welcome to part 3, that is the last part of lesson 7.5 for all grade 10 math advanced students. Today for this lesson probability and multiplication rule, we will solve questions from the book end of the lesson. But before that, let's review a little bit about dependent and independent. So I've taken a question from the check from the book. Here you need to just tell which event is independent, which is dependent, and also give a reason. Definitely you should know the reason why you are saying it is independent or why you say it is dependent. So let's do the first one. So of the $100 that Ree has to spend, she wants to spend $59 on a blouse and $54 on some jeans. So she has to buy two things and she has a total of only $100. Now she's spending $59 on the blouse and 44 on the jeans. Are these events independent or dependent? So let's say the first event is the money that she spends on the blouse and the second event is the money she spends on the jeans. Now, for example, she buys the blouse which is say $60. Then she has to spend less money on the jeans, only $40 left, right? So 60. So the total money because that she has is fixed. So if she spends more on the blouse, she has to spend less on the jeans, or if she spends more on the jeans, she has to spend less on the blouse. So definitely it is an example of dependent events. Now, second question, re-ask each of the three store associates which handbag they prefer. Now, these are three different stores. These are three different people, three different store associates. So their choices may be different. There may be no connection between their choices. Maybe one store associate likes one handbag, the other doesn't. So these are independent events. Their choices are not at all connected because they are three different individuals. Last repurchases a handbag and a belt. Now, she wants to take two things. One, a handbag, so two, a belt. Now, she might like a handbag from a particular store, but in that same store, she might not find a suitable belt. So she goes to another store. So her choice for the handbag and belt is completely different. Maybe she will like a handbag which she can use for her office, but she may choose a belt which is of a different color, of a different variety. So that is completely disconnected. So it will come under independent events. That's how you copy and complete the table and you choose which event is independent, which is dependent. Remember to give the reasons always. Okay, so now comes the book questions. So these are the practice questions which are very, very important given at the end of the book. I will be selecting a few questions from this one that I will do uh, in the next slide and we will solve it together. We will first identify whether that event is independent or dependent and then use the multiplication rule. So let's get started. I will be choosing question 4 and 5. These are important and let's solve them in the next slide. Okay, so let's read question 4 together first and then we'll decide whether it comes in independent or dependent event. So a bag, let me draw a random bag, has 3 red, 2 green and 4 blue marbles. So let's do the total. 3 plus 2, 5, total is 9. So total 9 different color of marbles are there. We will just highlight the important information while we read it. Now, an event is that the marble is chosen randomly from the bag and it is replaced. It's not that I'm taking a marble and then not putting it back. I'm definitely replacing it. So if it is with replacement, then it will definitely be independent event. Yeah, because the probability will not change, the sample space will not change. Even if I get a green color, red color, blue color, I'm putting it back before the second marble is chosen. Now what do you need to find? You need to find, last sentence is very important, probability that both marbles are blue. So I'm concerned about the blue marbles here. Okay, so let's find. So we need to find the probability of both marbles blue. So the first marble blue, the second marble blue. Okay, and definitely because it is independent, I'm going to use the multiplication rule. So let's find the probability that the first marble is blue. So total how many blue marbles? 4. 4 out of these 4 blue marble, any marble can come, and the total is 9. So 4 over 9, this will become the first probability. Which formula I'm using? Basic definition, number of favorable outcomes divide by number of total outcomes. This is what I do. So that means my number of favorable outcomes is 4 blue out of total 9. Now, once I take that blue marble, I am before choosing the second marble, putting it back. So total number of the marble are still 9, no change. And now this time, any of the uh, 4 marbles can come. Now, imagine the first marble I take out is blue, but then I'm again putting it back. So can I say the total marble again becomes blue 4? So no change. So can I say both times the probability is same? So 4 multiplied by 4. Let's now do the simplification. You may use your calculator, and 9 multiplied by 9 is 81. So the fraction is 16 over 81. Now let's go to the decimal and the percentage. So 16 divided by 81, this will come decimal 0.1975, and if I want to convert to percentage, I multiply by 100. So this is going to be 19.75%. Now if the question says round off approximately, I can make it 19.8%. So this is going to be your answer for the independent events using multiplication rule. Let's now solve another question. So this is question 5. The forecast predicts 40% chance of rain on Tuesday and 60% chance of rain on Wednesday. So on two particular different dates, the chance of rain, are they connected? Are they disconnected? Definitely they are independent events, because if it rains on one day, I don't know whether it's going to rain on the next day also. It doesn't have any sort of connection. So these are independent events. I'm going to use multiplication rule to get my answer. So let's see what the question is asking. The question, last line we will read again. If these probabilities are independent, what is the chance that it will rain on both days? So I want probability for rain on first day Tuesday and probability of rain on second day Wednesday. So if we see, there are two options for the days Tuesday, sorry, and there is option for Wednesday. For Tuesday, the percentage that it's gonna rain is 40, and for Wednesday it's 60. Now we want rain on both the days. We want to find the probability. If both days it rains, how we do it? So we will use the multiplication rule. Let's multiply. The first percentage is 40 and the second is 60. So how much we get after multiplication? This is gonna come 24%. So now I'm not converting to fraction or decimal, because in the question it is given in terms of the percentage. So I will give final answer in terms of percentage. Okay. Now let me little bit change the question just to make it easy for you. If in the same question, okay, independent events, we want to find that probability it rain on first day and no rain on second day, what will change? Let's think. So probability it will rain on the first day Tuesday, how much? 40%. Probability it will not rain. So total percentage is 100. This is the percentage it will rain. So if 60% are the chances it will rain, then what is the percentage that it will not rain? 40%. So if you solve, just multiply, this will be 16%. Correct? Now one more, another variety I will give you. It will not rain on Tuesday, but it will rain on Wednesday. So probability to rain on Tuesday is 40. So not rain is 60. So 60 multiplied by probability it will rain on Wednesday, again 60. So how much will this be? Just do the multiplication. 60% multiplied by 60%. So this will come 36%. Okay. So even though the question just asks you for the rain on both days, I give you two more examples just to make it easy and understandable. Hope it is clear and useful. Okay, now I take from example 2 of your math book the questions which are behind. In question 6 to 9 that you see on your screen, you just have to say, are the events independent or dependent, and then definitely explain why you say so or give the reason. Let's do two of them. We'll do question 6. You roll an even number on a fair die and then you spin a spinner numbered 1 to 5 and it lands on an odd number. So there are a lot of events happening. First you have the dice. Now you know in a dice the number of outcome, any number 1, 2, 3, 4, 5, 6 in a fair die can come. Now you roll an even number means only 2, 4, 6. That's what you want. And the second thing in the same question is the spinner. You are spinning the spinner. Now it has what numbers? 1 to 5. So any number from 1, 2, 3, 4, 5 can come and you want a odd number. Now think, are these independent or dependent? See, one object is dice, another is spinner. Are they connected? Think. Yes, you're right. They're not at all connected. The number that will come on the dice and the number that will come on the spinner, not at all connected. So this is disconnected and therefore this is an example of independent events. Okay, let's do another one. We will now do question 8, 7 and 8, 9 you try yourself. In a bag of 3 green, 4 blue, marbles. So that means I'll just draw a bag. There are 3 green, 4 blue marbles. So total is 7 total marbles. A blue marble is drawn and not replaced. So this is a question on without replacement. So for example, first time I take out the marble and I take blue marble. That means probability will become how much? How many blue you have? Favorable outcome 4 out of total how much? 7. Now, a second blue marble is drawn after that without replacement. So I'm not putting the blue marble back. So can I say the total marble will reduce from 7 to 6? And because I already take out one blue marble out of the 4, so only 3 left. Did you see the probability change? The sample space reduce without replacement. So definitely this is an example of dependent events. That's how you find, you identify, you determine whether they are independent or dependent. I hope the reasoning and the explanation is clear for you and you understand how to do it. Tell me in the comments. Okay, now let's do some more questions. So I'm picking up here now a cards question, question number 11. So let's read it together and I will be solving it on the next slide. A card is drawn from a standard deck of playing cards. So I hope you know a standard deck has 52 cards and is not replaced. So this is a question on cards without replacement. That means it will come under the category of dependent events. The sample space will get affected. We have to use multiplication rule while we solve this. And then a second card is drawn. Find the probability that the first card is a jack of spades and the second card is black. Now, to find this probability, we need to know how many spades are there, how many black cards are there, how many red cards, how many jacks, all of that. So, for better understanding, to explain you how many cards of each category are there, I will explain this question in the next slide with the help of a picture of cards. Okay, so let's solve this question. Read together. A card is drawn from a standard deck of 52 playing cards and it is not replaced. Because it is not replaced, this is a question on without replacement. So the sample space is going to be affected. Outcomes will reduce. And hence this will fall in the category of dependent events. Let's use multiplication rule. We need to find the probability that the first card is a jack of spades and the second card is a black. So to understand what is the correct number of these cards, we need to look at this picture which I have attached. So let's go to spades first. Now in spades, I need only a specific card, jack of spades. So which one? This is the option. There's only one card which is in the favorable outcome. There's only one jack of spades and there are a total of 52 cards. So 1 over 52 will become the probability. Now next is the second card is a black. Now, how many black cards are there? Let's count. So, in spades, if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13 cards, but because this is without replacement and the first card already I take it out, the Jack of Spades. So, there are 12 left here. Also, if you look at clubs, these have another 13 cards which are black. So this will also be coming in the favorable outcome. So let's now solve. So the probability that the first Jack of Spades and the second card is a black we need to find. So let's do the multiplication rule. Total 52 cards. I pick from spades only one card which is Jack. So one favorable outcome divided by total outcome 52. Now once I take this card Jack of Spades, the sample reduces and one card is out, so only 51 are left. Now we need to show that the second card that I draw is black. So how many total black? 13 black cards here from clubs, and from spades I have 12. Why 12? Because one I already take out, Jack of Spades. So 13 plus 12, this is going to be 25. So the favorable outcome is 25. If you do the multiplication and the division, do the calculation. You may use a calculator, it's allowed. So this will come 25 divided by the big number 2652. Now you can convert this fraction into a decimal or also to a percentage. So if I convert to decimal, it's going to be 0.00942, and if I multiply with 100, it will convert to the percentage. Approximately it is 0.942%. Okay, this is how you do the cards problem, dependent events. Okay, I'll do one more question on dependent events. Now in this one we are already given a table, so let's use the table and read the problem. Also, while you read, highlight the important information. The table shows the color and number of jerseys available for the intramural volleyball tournament. If each jersey is given away randomly, what is the probability that the first and the second jerseys are given both red? Now, definitely this is dependent events because each person will get their own jersey. You are not exchanging, you're not putting them back. Now we are selecting out of all these different colors as blue, white, red, black. We are choosing red. How many are red? 25. Let's do the total also because we need to find the total number of outcomes. So let's add all the numbers. 20 plus 15 plus 25 plus 10. So the total is 70. Yeah, total number of outcomes. Now we need to find the probability that both the jerseys which are given are red. So initially out of the total 70 jerseys, one red is given. There are 25 options to the first boy, and then randomly after you give that back the total number reduced, and out of 25 also one jersey is already given, so 24 are left. It reduces. Now we can go ahead, do the calculation. Use your calculator. So 25 multiplied by 24, this is going to be 600. Similarly for the denominator, it's going to be 70 multiplied by 69. That's a big number, 4830. Simplify this. If we simplify the fraction, it will come out to be 60 divided by 483. You can go ahead, do the decimal also and the percentage. So the decimal comes out to be 0.1242, and if I multiply with 100, approximately 0. Sorry. So after I do the multiplication, you know the decimal moves to the right by 2 places, so 12.42%. So these are the chances in this question for randomly selecting the jersey, both red in color. Okay, so let's do some more questions. I'm going to pick up question 16 from this slide. Let's read it together and highlight the important information. The probability that the students take geometry and French at Saul's school is 0.0064. So here in this question, the probability is given in decimal. So we will give the answer in decimal. Okay. The probability that the student takes French is 0.45. Again, it's a decimal. If taking geometry and taking French are dependent events, so they are already telling us that this is a dependent event. So let's write The formula for dependent events, multiplication rule. This is the formula. Okay, now it says if this is dependent event, what is the probability that the student takes geometry? So what are the two subjects? Let's say that event A is the probability that the student take geometry, and event B is the probability that the student take French. Okay, so out of these three numbers, one probability, two, and three, two are already given to you, the two decimals. We need to find the third one. So we need to find the probability that the student takes geometry, P of A. This is what we need to find. So let's keep it P of A. And the probability that the students take geometry and French both, means probability of A and B is 0.064. So I just put the value. Similarly, probability B over A is given. The probability that the students take French 0.45. Yeah. So now we need to find the probability for a student taking geometry. So the probability that the student takes geometry, we divide these two decimals, 0.0064 divided by 0.45. Let's see what it comes. You may use your calculator. So 0.064 divided by 0.45. Yeah, so it is again a decimal, 0.142, and yes, it's a recurring decimal. You can give your answer in the decimal. So the probability that the students take geometry is 0.142%. Okay, similarly try the remaining questions. If you see question number 17, this is a question on independent events. So again, you will use the multiplication rule. There are two events given. One is in percentage 43% for after school club, another is 28% for sports. What is the probability that the student is in an after school club if he or she also plays a sport, if being in club and playing sports are independent events? Yeah, so you will now use for this question the formula for independent events. So let's say A event is the event that the student is in after school club, and B is the event that the student is in sports. So what formula we will use for the independent events? We will multiply the two probabilities, right? So the first is the probability that the student is in after school club. It's given in the question, 43%. And the second for sports, 28%. Now because this question, the values are already given to you in terms of percentage, we will keep the same. The final answer we will give in terms of percentage. So just multiply the two, 43% multiplied by 28%. So this will give 12.04%. So approximately, because independent events, just directly multiply, use the multiplication rule. So 12.04% is the answer for question 11. Okay, so from this slide, we are going to solve question 23 and 24. Let me do 24 here. It's a very short question. Use the formula for the probability of two dependent events, probability A and B, to derive the conditional probability formula. It's very, very easy. If you know for two dependent events, A and B, if I want to find the probability of A and B, we use the multiplication rule. So we multiply the probability of the first event with the conditional probability B over A, or the probability of event B given that event A has already occurred. So from here we can easily do the formula for conditional probability. So if I want the value for this conditional probability, I'm going to move my probability of A here. Here it is multiplication. So when it goes on the other side, it will divide. So I divide both sides with probability of A. And when I do that, this one cancels and we get the formula for conditional probability. So the formula for conditional probability B over A, or the formula for conditional probability of event B given event A has already occurred, is given by the formula probability of both events A and B divided by probability of A. So this is how we do the derivation for the conditional probability formula. Let's solve question 23, the card question, on the next slide. Let's do another very, very important card question again from your book. This is question 23 at the end of the lesson. So it's a hot or a important question, tricky one. Let's read. Sam is doing a trick with the standard 52 playing cards where she begins each trick with a fresh deck of cards. Her friend Tracy randomly selects a card, looks at it, and puts it back. So is it with replacement or without replacement? Because we are putting it back, it is with replacement, so the probability will not get affected, the outcomes will be the same, the sample space will not change, and therefore this will come in independent events. We can go ahead and use multiplication rule. Okay, now let's see what is the situation. Sam randomly selects the same card. Are the events independent? So there are two different friends. One is Tracy, one is Sam. Now both are choosing the cards one by one, and once Tracy picks up a random card, she just looks at it and puts it back. She is replacing the card. The sample space is not getting affected. It is again total 52 cards. So are the events independent? Definitely yes. These are independent events because the card that the first girl, Tracy, will pick up and the card that the second friend Sam is going to pick up is no way connected. Yeah. So what is the probability that they both pick the Queen of Spades? Huh? So Queen of Spades. So this is again a flowchart that I have put here for you so that we can understand which cards are we looking at. So total 52. Out of this there are 4 sets of 13 cards each. Huh? Out of these 13, spade, club, diamond and heart, we are just looking at one of this um, card which is the spades. So I will just highlight spade for you. And in this spade, we want the queen of spades. So how many queen of spades is there? Just one, right? So now let's solve the question again. So what is the probability that they both pick the queen of spades? That means the first girl, Tracy, is also picking the queen of spades. I'm just denoting it with QS. And the second Sam is also picking queen of spades. And then she is replacing back. Means if the first is getting the same queen, she's putting back by chance, by a coincidence. It's a rare coincidence, by the way. The second one is also getting the same card, queen of spades. And the sample space will not reduce, it will not get affected because it is um, the same card and there is only one favorable outcome. There is only one queen of spade. So 1 out of 52, that will become the probability for the first friend Tracy to get the card. And similarly, if she puts it back, sample space is again 52. There is total 52 cards, no reduction. And the second one also gets the same one. So it's a rare chance. It's like not so common situation. So if we just see after we apply the multiplication rule, it's a big number, 1 divided by 2704. So it's a very rare probability. So that's why it is a very small decimal, 0.000369. So if I multiply with 100, it shifts here. So approximately the probability is going to be 0.0369%, which is very rare, definitely. Yeah, so this is how we solve the question. That brings us to the end of today's session. It's a long video and we've covered as many questions as we can for probability of dependent and independent events. I hope the video was useful, and if it really helped you, give it a thumbs up, like, share and subscribe to my channel, and let me know in the comment section which video you want me to cover in the next session. All the best, all my great 10 advanced students.